Welcome to our channel Storm Rider. When we talk about the future of long-haul air travel, the Boeing 777X stands out as one of the most ambitious aircraft Boeing has ever created. It's not just a bigger or newer version of the older 777, it's a deep redesign that blends advanced materials, next-generation engines, digital systems, and new cabin features to create an aircraft that aims to set a benchmark for comfort and efficiency. Imagine a plane that is huge but graceful, powerful but quiet, designed for distances that stretch across continents and oceans without stopping. That is the idea behind the Boeing 777X, especially the upcoming 2025 production version that airlines are preparing to introduce. The first thing that captures attention is the wing. Unlike the earlier 777 models, which used traditional aluminum wings, the 777X uses a carbon fiber composite wing, the largest single-piece composite wing Boeing has ever built. Composite wings are lighter, stronger, and can be shaped into highly aerodynamic curves that metal wings simply can't match. The curvature gives the 777X an unusually elegant shape, more like a glider in its wing profile than a typical heavy commercial jet. Because a longer wing means more aerodynamic lift and less drag, Boeing stretched the wingspan to over 71 meters, making it one of the widest ever fitted to a commercial airliner. But a wing that wide presents a huge challenge on the ground, especially at airports not built for extremely large aircraft. That's why the 777X includes one of its most famous features, folding wingtips. The last few meters of each wing fold upward after landing, reducing the wingspan enough for the plane to use standard long-haul gates. This is a smart compromise. The plane still enjoys the aerodynamic benefits of long wings in the air, yet it can operate at most major airports without requiring new infrastructure. The folding mechanism is designed with multiple safety locks, sensors, and backup systems to prevent accidental folding during flight. It's a technology inspired by military jets but made safe and reliable for commercial operations. Next, the engines. The GE9X engines on the 777X are among the most advanced turbofan engines ever developed. With massive fans measuring roughly 3.4 meters in diameter, each engine is almost the width of a Boeing 737's fuselage. But size is just one part of the story. These engines are built with new materials, including ceramic matrix composites, which can withstand high temperatures while being lighter than metal components. This lets the engine operate at a higher pressure ratio, making it more fuel efficient and cleaner in emissions. The GE9X also has one of the highest bypass ratios of any engine, meaning more air passes around the core, creating smoother and quieter thrust. The result is a powerful engine that uses less fuel, produces less noise, and requires fewer emissions control systems than older designs. Performance-wise, the 777X is built for extreme long-range missions. The larger 777-9 variant is expected to carry over 400 passengers in a two-class configuration while offering a range of 13,500 kilometers or more. This means airlines can fly routes like Dubai to Los Angeles, Singapore to London, or New York to Sydney with fewer limits on passenger weight or cargo. The smaller but longer-range 777-8 is designed for ultra-long flights, potentially competing with Airbus A350-1000 and other long-range rivals. What makes the 777X appealing to airlines is how it combines high passenger capacity with long range and relatively low operating costs. Instead of flying a larger four-engine aircraft like the old Boeing 747 or Airbus A380, airlines now prefer efficient twin-engine jets like the 777X that consume less fuel and are easier to maintain. Speaking of maintenance, the 777X inherits many digital and structural improvements from the 787 Dreamliner. Its systems continuously monitor engine health, wing stress, hydraulic performance, and cabin pressure using sensors placed throughout the structure. These data points help airlines predict maintenance needs before issues occur. The composite wings and lighter materials mean fewer corrosion concerns and a longer structural life, reducing how often the plane needs heavy checks. Inside the aircraft, Boeing has focused heavily on the passenger experience. The cabin is noticeably wider than the 787 and offers more shoulder room for seated passengers. This extra width means that even in economy class, seats feel slightly roomier depending on airline configuration. The windows are larger, placed at a higher level, and use electronic dimming technology similar to the 787 Dreamliner. Because the fuselage is made from advanced alloys with improved pressurization capabilities, the cabin can maintain a lower effective altitude, often equivalent to around 6,000 feet instead of the 8,000 feet common in older jets. This reduces fatigue and makes long flights more comfortable, especially on journeys longer than 10 hours. The lighting system uses fully programmable LEDs which can mimic sunrise, sunset, or soft ambient tones that help passengers relax. Many airlines are expected to introduce customized lighting themes, making each phase of the flight feel calmer and more natural. Air quality is also improved with better filtration systems, adjustable humidity control, and more efficient air circulation. These features may seem subtle, but on a 12 to 16-hour flight, they make a major difference in how refreshed passengers feel upon arrival. Business class and first class cabins, depending on the airline, will likely showcase the 777X's spaciousness more dramatically. With more floor area than earlier 777 models, airlines can place larger suites, doors for privacy, lounge-style seating, or even small bar areas in premium cabins. Because of the aircraft's quiet interior and smoother ride technology, premium cabins can feel like high-end hotel spaces rather than just airplane seats. From the pilot's perspective, the 777X cockpit includes updated flight displays, larger touchscreen interfaces, and advanced fly-by-wire controls derived from the 787. The folding wingtip control is integrated into the cockpit, with automated warnings, lock confirmations, and checklists that ensure the wingtips are correctly positioned before takeoff. Boeing has incorporated improved gust load alleviation systems, meaning the aircraft can adjust the wings in real time to reduce turbulence effects, resulting in a smoother ride for passengers. What sets the 777X apart from many other next-generation aircraft is its balance of capacity, comfort, and efficiency. It's designed to carry a large number of passengers across long distances, but without the high operating cost of older large aircraft. It aims to be eco-efficient, offering airlines a more sustainable option through lower fuel burn, reduced emissions, and quieter operations. At the same time, passengers get a premium travel experience, with more space, better lighting, improved air quality, and a quieter cabin overall. For airlines, the 2025 Boeing 777X represents a reliable long-haul workhorse with advanced systems and reduced maintenance demands. For passengers, it feels like stepping into a more modern and comfortable era of aviation. And for the aviation industry, it stands as a major leap forward, a combination of engineering innovation, fuel efficiency, aerodynamic excellence, and refined design.